And welcome. It's Renato here. And yeah, this is my stream, No Monade. Again, working on making some pretty balls that bounce around and do sounds. So, the first stream, we figured out the MIDI, how to make them emit MIDI. The second, we made them pretty. Okay, they were white balls on a gray background. Now they look cute. There's this effect; they become white when there's collision, and they have this trail. I think it looks decent enough for now. And now, I guess it's time to put it all together. Yeah, maybe just to check, since I refactored last time, let's check if the MIDI is actually working. So I think probably this doesn't belong here anymore, this line. Ah, no, wait, no, it actually does, because notes get assigned here, right? And when I create the balls, or they should be at least, yeah, here. Right, note. Yeah, here I was, to be honest, quite uncertain on what is this doing, because this looks like a list with a number between. Yeah, because I'm passing the index of the list, I think, not really. Let's see how I'm using this. So of course I'm assigning that note str to this dot note, and this dot note, where am I using it? No, sorry, I misspelled it. This dot note, I'm passing it to send MIDI. Note, no, I'm okay. No, this is not an index of that list. It's actually, it's supposed to actually be, but then I want to put here a console.log statement, because it's not clear at all how that might work. Yeah, let's put console.log note enable MIDI, of course, has to be true. Index. Yeah, you see, this is not. I don't know if this was working, but it's not supposed to work, right? And in any case, now I have yesterday, right, in the stream yesterday, I coded this nice function because I needed the same functionality also, right? So choose random from array, so I can just do that from node pool. Okay, if no, sorry, I can just do that. So here, choose random from array node pool, and did it import it? Yes, it does. Okay, yes. Now that's the right thing, and it's assigning the right notes. And by the way, we can maybe comment that out. Actually, for debugging, we could have the note being printed inside, but that's, yeah, not really needed for now. Where's that log statement? Here. Okay. Okay, yeah. And now I have Bitwig over here that's muted. So if we unmute it, we should be hearing. I mean, yeah, it's something, right? Something's happening, but as I mentioned yesterday, it's rather chaotic, right? Because these are like kind of like gas particles, right? Just like running around with no pattern at all. Of course, the outcome is going to be quite noisy. We need some sort of pattern, right? So the first thing I'm going to try, sorry, pouring some tea. The first thing I'm going to try is to I kind of, what I did now is kind of like a really small and stupid game engine, right? With the collision, the graphics and whatever. And now I can think of like making, like it would be like, say, if it were a video game, like levels, okay, or we can call them scenes. So like different configurations. And the first one I want to try is to just have a, put all the balls on the vertices of a regular polygon, and just have them all start there. For example, all with velocity directed towards the center. So yeah, let's try to do that. How do we do that? Okay, let's go full screen of the code. Let's see. I'm thinking if I should make an. So basically, what I wanna change is this part here, right? This is where I'm creating the balls, because then the update. Sorry, yeah, this is basically this is the setup, right? This is how you define initial conditions, and then this is the the update, right? So I'm thinking, yeah, maybe this instead of sketch.js, I can just call this like I don't know, yeah, like scene random, and then I can copy it and call it scene polygon. Okay, and then we go and index.html and we change this from sketch.js to scene polygon. Okay, now nothing should have changed. Yeah, exactly, it's all the same. But once I go here, if I start commenting this out, okay, balls disappear. Exactly. So okay, how do we do this? Well, first of all, we have to position the balls, right? Now that's I'm looking here. Yeah, probably I'm gonna have to. I'm going to have to change a bit these parameters. Okay, balls I can keep, right? This will be the list of balls, and this could become like the number of vertices of the polygon. So we'll probably start with something like 6. Speed, mean, and speed variance. This probably will get rid of because let's see. I'm gonna comment it and just call it speed because I think I want them all to have the same speed. And also this air lower, high, no, I'm gonna have them all the same size. Because again, I want to create something that's, the idea is that there will be like billiard balls in a specific configuration that will repeat itself, right? Hopefully. That will create some kind of repeatable rhythm. And then of course we can play with it, maybe have some balls of different size, but to start, let's have them all the same. Also, the canvas is going to be square, but for now, yeah. Let's call R. Oh, I forgot what were the numbers there. Yeah, like 5, 10. Let's say R15. Enable MIDI, yes. Node, pull. That's another interesting thing, but I guess, yeah, for now, let's just focus on visuals. Another interesting thing in the sense of how I will manage the MIDI here, because I could, like now, what I'm doing now, right, is picking a random note. Probably now, since I'm doing something with more structure, maybe it would be nicer to not have it like that, but yeah, whatever. Let's start with a square canvas. Let's start with the random MIDI notes, okay? And yeah. Okay, so now we have to compute. The first thing we have to do is to compute these points, right? So we have we will have to use sines and cosines, right? We have the full angle, that's 2 pi. and we have to divide that by n. That will give us the increment of angle, and then each time we compute the new angle by adding this small increment, right? Oh, yeah. Okay, so basically the for loop can stay, right? Maybe instead of I, let's call it k, because that's how you usually do. It's purely aesthetic thing, but that's how you usually do, right? When you have multiples of a fraction of 2 pi, you say 2k times 2 pi over n. That's what we will be doing. Basically, the current angle, current theta, will be k times math. I guess there is pi. Yes. Okay, so times 2 times pi divided by n, right? That should go all the way from 0, when k is 0, to when k is n minus 1. It will almost be 2 pi, right? If k were n, it would be 2 pi. For the moment, we let the random, we still keep the random note assignment, and we can create, and okay, now the other thing we have to do, we don't need to compute the random ball, but the thing we have to do is to compute the x and y coordinates, right? And that will have to be, of course, using the okay, well, one thing I forgot to do is define the radius, so the big radius, right, of the let's say of the I forget the English word, but basically if the smallest circle that includes the polygon, so like the vertices of the polygon will lay on this circumference, and we call that simply big R, and let's say that's 150, and it will be 300 out of a 600 square. Yeah, that sounds, so it will be, the diameter will be 300, right? That should fill up like half of the canvas. We can start with that. And then the x will be this r times math.cos of the current angle, and the y will be the same thing but with the sign. I hope my trigonometry is not that rusty, but hey, could totally be because I really haven't been doing much of any of that in many years, which is pretty basics maths, I mean, but yeah. So now we set just to see if the displacement is correct. For the moment we set no speed, so they will be static. Ball radius, let's call it r. Color, okay, we can keep the random colors. Note string, note duration, interesting. Let's just have it. I think this is in milliseconds. I should have specified it in the variable name. That's always, I always prefer doing that. When you just write like this, you don't know, is it what is it, quarter notes at 120 bpm? Is it seconds, hours? I guess it's milliseconds, but let's check where that is used. Where is it used? I think when you write, when you do send MIDI note, and the send MIDI note also I haven't written, but it's not written anywhere. Okay, let's assume it's milliseconds. So let's call it here milliseconds. And let's call it here milliseconds, and then even here milliseconds. And then in scene polygon, this becomes milliseconds. By the way, you have to fix also the other scene then. Okay. So half a second, right? Yeah, we have to pass the sketch, right? Yeah, I mean, this should work. Haha. Wait a moment. Because the x's, Yeah, of course. So this is the x relative to the center of the canvas, right? So first we need to compute the center of the polygon, and I guess it will be the center, right? Oh well, can't be bothered to learn the JavaScript rules for priority, so just to be sure, I'll overdo it with parentheses to avoid any weird bugs. And there you go, it's like a nice hexagon. And if you change this to 7, we get what is it? I don't know the name, but hey, it's a regular polygon of 7 vertices. Okay, this is quite satisfying already, to be honest. Now we have to compute the vector for the speed, right? We want the speed to go towards the center. So how is that vector look like? Well, it's gonna be really the inverse. It's gonna be, I think, just minus x minus y, now that I think about it. Maybe yeah, it will be super fast like this. Wow, well, that's freaking cool. It's not what I wanted, but hey, I'll take that. Let's hear how that sounds. Let's try it with another synth. Yeah, way too many notes. There's obviously some. No, there's obviously some. Let's mute the master. There's obviously some thing happening here, right? The speed, because I'm multiplying. Where is it? The x is getting multiplied by r. This r factor, which is quite large for the displacement. The speed, if you remember, was on the order of like 1. Now it will be on the order of 100, so like 2 orders of magnitude greater. And probably it's moving, the balls are moving so fast that they're getting displaced so much between each frame that you don't even see you don't perceive it as a continuous movement, right? So we need to renormalize. The direction is right, I think. I still have to verify that actually, visually, but we need to normalize these directions, right? And then multiply by speed. So how do you normalize? Well, by the way, it's a pity I have to do it in the for loop because I'll do it 1,000 times over. But okay, actually, it's not that simple because I have to normalize only this part, right? And then this has to stay the same, I think. I have to normalize this part, so this obviously has norm r, so maybe no, you're right, I can divide by r. Wait a moment. No, this. Oh, okay, it's getting tricky here. So if the coordinates were at the center, what I said until now I think is correct. Like what I said until now would stand for the coordinates at the center. But since the coordinates in the canvas, like usually right in software graphics, they start from the top left and the x increases as you go right and the y increases as you go down. Kind of like matrix index notation. Then, and my polygon, the center is down here. Yeah, having trouble visualizing the math. But in any case, so what's Vx? Vx has to be a vector that starts in this point xy and points at center x, center y, correct? So will this be right? right. So I'll put the full screen again so I don't see the live updates. Something like this might be right. Minus x divided by r. And of course with a minus sign. No, the minus sign is already taken care of. So this is Vx, this is Vy. Not really working. Has to be multiplied by the speed, right? Again, so like this again. So this is the direction, but again, also center x, right, has a huge modulo, huge norm. So I think this is the right direction, but then we have to tell it Vx has to be divided by math.norm or abs. Yeah. No, but this is wrong because you're dividing by the only one coordinate. Has to be divided. So we have to first compute the norm. The norm of the whole thing. V norm. And this will be math.square root of Vx squared plus Vy squared. Yeah. And now I divide Vx by the norm and I divide Vy by the norm. Well, off they go. What the hell is happening? Why did they all go down and right? Well, again, that looks, you see all these bugs. It's like, yeah, that's not what I wanted, but it looks cool. You see what I meant by structure. Now there is, let's see how that sounds. Wow, that's so cool. Damn it. Let's reload the page over here. Why doesn't that collide? That's also weird. Now the notes are still random. That's still something not really helping emerging patterns. There's a lot of weird stuff going on here. First of all, why don't those balls collide with the wall on the right? Ah, is there something hard-coded with them? Is there something hard-coded with respect to this check walls function? Yeah, sure, it doesn't. It's using this the text, this dot r, sketch width, sketch height. Okay, so one thing at a time. One thing at a time. The x and the y's are correct because they display right on a polygon. The Vx and the Vy are not, and forget about this normalization for now because this doesn't really change that direction. All right, this only changes the amount of speed. Ah, and by the way, I should have multiplied here. I should write this as speed times Vx divided by norm. So I can then do as intended, I can change the global speed. Let's see if this, whoa. Why did I change the speed? It's just one. Ah, sorry, because here there's this. Okay, and now I put 0.1 and everything goes slower. Indeed. Okay, so at least that part works. Yeah, still no collision, but before the collision, why is everything going down and right? So I have a point. Let's write something here. Point P as coordinates xy. Okay. Yes. Relative to center x. No, relative to sorry, let's put this here. Relative to canvas origin. Yes. And r cos, let's call it CTH for current theta, r times sin CTH relative to CX, this stands for center X, center Y. Correct? Yes. Now speed should have coords, I think, okay? Because so this vector here, again, thinking in this coordinate system, okay, which is simpler, right? It's at the center of the polygon. Wait a moment, but the y, that's the problem I'm making, the mistake I'm making. The y flips, right? Because the y, so usually when you do trigonometry, right, when you do maths in general, right, in a two-dimensional plane, that the y is pointing upwards. Here in the canvas, the y is pointing downwards. So that might affect things. I think so. This still looks right, but it's probably not what I intended. Like, probably this is going. Wait, what changes here? So center y starts as that. This is increasing. This is increasing linearly. So like no, it's just a number between 0 and 2 pi. But when I do the sinus of it, yes, I get at first, okay, like in the first 180 degrees, I get this is a positive number. And so as I'm adding it to it, y is actually going down. So actually this circle is being drawn. We can see it easily if we say instead of k equals 9, let's say k equals 3. This will be the first 3 dots of the polygon, but in counterclockwise order. Let's put speed 0. Yes, exactly. So you see if I put 4 now, another one. Exactly, which is the opposite of what like you usually think. It's not necessarily a problem, but just to understand like what's going on, because the y is inverted. Okay, that being said, the xy, okay, if here there's the center, the x, the position, right, relative to this, it's a vector starting from here and going here, starting from here and going here. Like, for example, let's take this, right? It goes straight down, but the actual vector goes like this, right? So what I want is to have the speed of it going straight up. Right, but I don't care anymore about the, yeah, that's my mistake. The speed doesn't care about this offset, right? I can invert just this part, I think. Let's see. If well, let's keep this as a backup, but I think, but I have to invert though. This has to be minus, I think, I'm not sure. Well, right, yeah. This we switch back to n, and the speed we put back to 0.3, for example. Now they all go. They're not parallel, by the way. Well, this is interesting. Again, it's like not what I wanted. By the way, I saw another interesting bug. When two balls collide, and I know why that happens, only one of them is blinking. Oh, this is so cool. Let me hear how it sounds. Let's reload the page. Actually, let's mute. How do I? There's only one voice in the center, I think. I think it doesn't sound that great, but I also think this thing has so much potential. Like I'm getting hyped by my own by my own ideas. Okay, even if they're buggy still. Let's try. I don't know if I should save this. I actually save this, and it looks so cool. I think it looks cool. So I think, by the way, that if I achieve what I want, okay, all this balls going in. I'm not 100% sure of this, but I think it will be very boring, right? Because it will just... yeah, I'm not sure. Maybe it depends on the number of edges, right? I'm not sure how they will interact. But yeah, this... maybe I should save this. Yeah, I should, like this... I should write a comment, like, all going down and right. And here this should be... Let me check if that's, wait. If that's true. Like this they all go down and right, yes. Like this they go all going up and left. Yeah, up and left, but not parallel. Okay, but now we want to get it right. Right? Yeah, we want to get it right. So, okay. Okay. I know because I'm doing x and I'm using x and y for the velocity, but x and y has inside has this center x, right? We don't need that. We want this, so to not redo the computation. Let's call it, I don't know, x from center. And then y center, and here x from center, y from center. And now, no, sorry, here, instead of x and r, we use this x from center and y from center. Yay, it works. That's what I wanted. Boom. Oh, wow. I think there's some rotation in it because of the asymmetry, because the collision detection... Wait. Ah, now I get it. That's why the collision detection wasn't working, because I was covering the canvas with the debug window. Okay, well, that's one less bug to worry about. This is cool. Let's listen to it, but with a higher speed a bit so I don't go crazy. Let's reload this. Ooh, why no notes coming? Are notes only on the collision? Ah, they're not on the walls, yeah. Oh, but I should totally put notes on the walls as well. I should put notes on the walls, at least as an option. I don't wanna, because now you see, now that's the thing. Now that I started, why don't they overlap perfectly? Ah, because Bitwig is... Okay. Now that I'm using the same class, right, for different things, I have to be careful when I change stuff here because it might affect my previous thing. So let's, I guess, add an option. How can I have it with a default value? I want, because right, I want to add an option with a default value that's the same as what it was previously. Okay, so I have this JS class, and I want to add an option to the constructor, that has a default value. Please help. Dots. Yeah, by the way, I would like it formatted like that. I don't know how I can tell. I'm using this formatter prettier, but it's not really. It's not like I configured it or anything. I just installed it, but maybe there's some settings. Bah, come on, I don't have time for this. Whatever, I'll just copy paste this. But it looks much nicer, not like this. Much more readable. I use in the Python, I always use a black, which I love it because it's so strict. It doesn't let you do what you want. But that's actually a great thing because it you just hit format and it deterministically puts the code in a specific format. There's very few things you can change, like you can it will let you have either one or two empty lines between function definitions. You can choose that, but most of the things, if it's written in a once you write it and you hit format, you get that format consistently. So like here, if it's longer than a certain amount, it will automatically align all the arguments vertically, or you can force it to do so by just adding a trailing comma, but you see here it's not doing it, which I find very annoying. I was hitting the format shortcut, like this is what I want. And now if I format, you see this is what I mean, it's not deterministic, because now I'm hitting format, yeah, okay, it's adjusting this horrible space, but this, it's leaving it like it is. And when I had it on one line, it also was leaving it as it was, so. Yeah, I like it when it's more strict. New option. Okay, so how do we call this option? Yes, send note on wall collision, and the default value should be false. Okay. I'm thinking. I have this variable. Should I put the... So I'm using this function, right, post-collision check, to do some computation on this delay factor, which is used for the trail. I wrote this stuff yesterday. I already forgot what the heck it's doing. No, I think I'll just put it here. I'll just add here. Okay, if this collide with walls is true, and where is it? And this dot send MIDI on wall collision is true. Okay, then we use the same thing. Well, and also right, and also the note is not null. Also, this would be nice to format on multiple lines, but whatever. Okay, and in synth polygon, we add ball creation, send MIDI note on collision equal true. Ah, sorry, no, this is a dictionary. Yeah, we made it like so. Okay, so let's see if that works, if it will. No, it doesn't. Why not? Oh. Wait, is there... Well, let's, first of all, let's enable Let's enable a print statement. Here. Just so I don't have to every time open that. Yeah, I was writing this, which is Python, right? Now you'll do that. Sending notes. Now, of course, there were. Yeah, no, now it doesn't get called. It doesn't get called collide with false. So this if, right? If, else, if. If, else, if. I think this is correct. Like, there's no break or return happening in here. And it's true. Send MIDI. So collide with false. This gets set to true. Here gets reset to false every time before a collision check. By the way, actually I could move, you know what? I could move this this here in the post collision check just for one reason. By the way, yeah, because like this, by the way, it's gonna send the same note multiple if ball A collides with ball C and D. Sorry, A collides with B and C at the same time. A will send twice the note, right? Because this gets called for every other ball. Yeah, so now let's move, let's basically remove this, we can comment it, and move, did I copy it? Yeah, let's move this here, so so here instead of this we will have a complex condition, or this dot collided with other ball, that's true, okay? No. Like this, yeah, I mean, I can do it, but by the way, it's not triggering now. So there's something wrong with this if. There's something wrong with this if. Maybe I have to put. Let's. This if. Maybe I have to put 3 equal signs. I'm not sure about the difference in JavaScript. This if is never triggering, even though I'm quite sure, but I'll not tell that to GPT, the variables being checked are all true. Is the syntax wrong? I should check, yeah. Maybe they're not all. Wait, but do I set? Okay. Yeah, I'm a genius. What a genius I am. Yeah. Of course. See now all of those, and now more nodes, right? Yes, more nodes. But okay, but now it's not backwards compatible, the code, because like this is not doing what it should, right? What do I mean is that in the if like this, now we need, I think, some more clever condition checking. Like it should always send it, right? It should always send a note if it's collided with the wall. So let's double this. Either. So also this node null, also this has to always be there, right? So let's say if this node null and end. And now we have a series of ors, so like it collided with a ball, Or now there's a double if here. This dot collided with walls, and yeah, something like this. I think now this is right. So like this, the node has to be defined, okay, always. And then we have this two conditions: either it collided with a ball, or it collided with a wall, and that variable is set to true. Yeah, I think this is right. I think this is right, so we can go back and hear the results. Here we have Bitwig. Let's reload the page. I think, you know what, the balls are too small. What is it? Let's make them bigger. Let's make let's make a triangle. The synth has some, yeah, because I'm never sending note offs, right? I think it's never sending note offs. And the synth has infinite sustain, which I think I tried fixing already last time, but I don't remember anymore how to use Bitwig. My god. There's a delay, a reverb. Does it have infinite feedback? No. No, because they're already here, right? And the first effect in the chain. So it must be here, but the release is not infinite. I'm not so familiar maybe with the synth. Let's see if it has modulators. Yeah, that won't work, because if I play the clip, I mean, of course it will work because it has note offs. Right. Now we got two note ons, no sign of a note off. You know what? Let's just look for another sound. I'm getting bored of that anyways. Now why would I put an organ? Something plucky was actually not a bad idea. Pluck and bow, and I have to put here this. I think this is much more appropriate actually as a starting. I saved the Bitwig file and it reloaded the page because it's watching the directory, right? I'm saving the Bitwig file inside here. Okay. Let's try like 7. I think some notes are still hanging, but at least it's less annoying with this synth. 7 is cooler. Seven is cool, and let's try. Okay, let's try something different now. Let's go on the notes. Let's put this to false. Also, an easy way to mute the sound, except it doesn't. Well, we can keep that as background. It's not so annoying. So 7, right? 5, 7. We can do scales like 5. It's a pentatonic, right? 2, 3, 4, 5. Yeah, pentatonic. As the name suggests, penta has 5 notes, right? Let's try to make a pentagon and have um, each note in the note pool be assigned to a successive note in the scale. And to do that, we can do like this. Well, we have to here write, let's write in this variable the pentatonic. Remove this. I'll remove also the music because it's, I don't know why it gives me anxiety. Okay, let's do a C minor pentatonic. So you have the first, the minor third. Here you need the fourth, so F3, the fifth, and the seventh minor. So we have it 1, 2, 3, 4, 5. Yes. And then let's define a new variable called let note mode, and this can be it's a scale. Okay, and let's put here random. Yeah. So we can preserve the old behavior. Let's remove this stuff. We can preserve the old behavior here. Okay, now it also gets complicated. We define here a small function. Get next node. We pass it the index k. Okay. And then we look at that node mode. If node mode is equal random, then you return this, and here you put get next node of k. Okay, how is it? Else if, right? Here I have a bunch of them. It's not elif, no, it's else if. Node mode equal scale. Sorry, we have to return this. You return node pool, and the index will be here. I will need modulo division. Okay, like this is how you write it in Python. Obviously, it doesn't work in JavaScript, but just to get that. Okay, here let's ask ChatGPT modulo division in JavaScript, which I already asked yesterday, but I forgot because I didn't use it in the end. So this is the returns one. Okay, yeah. Wait, is that what I want? Yes, I think. Node pool. Okay, yeah. Okay, and get next node. Okay, yeah. Else we can put just a catch all, return null. Okay. Actually, would be handy now to have that feature where every ball has the node string written, at least in the bug mode. So p5.js show text. That should be trivial, right? Text and then the coordinates, exactly. So we will add a new parameter to ball, and we will call it show node string false, and then you tell it this dot show node string equals show node string, and when we display, okay, if this dot show node string is true, then we tell it this dot sketch dot text this dot node string at position this dot x, yeah, this dot x, this dot y, and don't know about the text size, but let's just try it. Shown. Why is it? Okay. True. Nah. It's not working, is it? Show node string. Show node string. This dot show node str. Show this. Long showing text and then there is undefined. Ah. Ooh, undefined. Ah, sorry, it's just this dot node. Yeah. Cannot read the properties of null. So this dot node, where is it used? Maybe I should add that check just to be sure. Why is it no? It's sending the MIDI notes, right? Ah, no, I right. I put enable MIDI false. That's why. Maybe instead of having it like this is a bit artificial, right? I should pass enable MIDI as also as a parameter to both. This will break backwards compatibility, I guess. Yeah, who cares? Who cares? We live on the edge. Let's put it here. Enable. Actually, let's call it disable. Like this, we'll have disable MIDI false. Okay, like this it will be. No, I'm not sure. But now I need to add another check in that huge if. Oof. I could just. No, let's keep it like this. If you tell it to send MIDI, it should send MIDI, right? Yeah. Okay. Well, that helps. X, yeah, it's not centered because I should calculate the bounding box of the text and then offset at that, but this is fine for debugging, right? So sorry, let's reload. Is this the correct notes? C, E, C. Ah, no, again, we are doing it bottom down, counterclockwise, right? So, oh, they move too fast. They move way too fast. Let's try like this, huh? So C, E minor, E flat, sorry, F, G, B flat, C, okay. And if I put this, yeah, no, that's right. I mean, that's modular division, right? If I put only two notes, well, let's put only three. Two is a bit. C, E flat, F, C, E flat, F, C. Yeah. Okay. So let's try this. Let's put all the 5 notes and let's put it on a pentagon. And now we have our nice pentatonic. And let's hear how that sounds. Put a speed of 1. Pentatonics are magic because anything you do and it will sound great. Yeah, see. Much better than a chord, huh? Well, I didn't think about it before. Pentatonics are always ultra cool. try something ludicrous. It's still kind of random, really. But yeah, it's improved, I would say. It must be, part of it must be, let me turn it off. Part of it must be the choice of the pentatonic for sure, but I think also the, having it more structured like this, right, like the polygon. Let's try slower speed. Like this is reproducible, right? Every time. Yeah, it's always that, right? The thing is, now I get it. In order to be a real, so in order for this to be a really more pattern thing, it has to at some point it should reach the initial conditions, right? And now here I don't think this will ever happen because of small numerical inconsistencies, right? Like let's try it on a square. You see, okay, so first of all, it's not aligned. It's not aligned with the box. But let's see how it works. You see, like this should continue like this forever. I bet you it won't. Or maybe it will. Because of small numerical errors. Eventually, yeah, you can see the ball on the right. There you go. Fuck, this is cool actually. I love this. And this, they will always, this is an interesting pattern. That's it. That's it. This is the stable condition. They won't ever touch themselves again. This is freaking cool, man. It's like, I don't know. Why? That's numerical errors. I mean, because they're going only up. Well, they should be. So, in theory, right, they start like this. Like this one here is going up. In theory, the velocity component of this on the x-axis is 0, right? It has only a y component. However, if you look at how we are actually computing it, it's this, right, Vx. We're taking, okay, r is a number, okay. X from center, it has this. Okay, so for the first, when theta is 0, yeah. Of course, when theta is 0, I guess math.cosine returns actually 1. Sorry, yeah, 1, yeah. The sine is 0. But, for example, when k, so here n is 4, right? When k is 2, what does this look like? Like, does this, maybe I should, by the way, write it another way. Maybe I should write it k. I wonder if this makes a difference. Let's try it. So we comment this, and we write here, first k divided by n, like that. will this be more numerically stable? Because okay, if like here there's 2 over 4, right? I guess JavaScript will tell you the 0.5 and then multiply by whatever this is. But if you write it like this, I'm not sure it will maybe carry out first this multiplication, right? This will be 4, and then there's times pi, and then at the end divide by n. I think this might be more stable numerically. Let's see. Which might be a bad thing actually artistically, yeah? Because it might be that it's more boring. But that's not the only source though of randomness. There's others. No, it's still not stable. You see that the ball on the right is slowly going more down. Yeah, now it's definitely more down. There you go. If there were no numerical errors, it would just keep banging like in the beginning, right? Yeah, this is where I thought because I thought the only source of chaos originally, I thought the only source of imprecision would be the collisions, but actually no. Even the oh, wow, we can print them. Let's try that. I'm sorry, this is just my math nerdiness kicking in. And just too curious, let's actually, at least during setup, this is setup, right? Yeah. Let's print console.log ball, let's say k out of, oh, and we know it, ball k has coords x, y equal x, y, and speed vx, vy equal vx, vy. Let's put speed to 1. Oh, it's not. Did I forget parentheses? Something obvious? No? What's the problem? Vx is not defined. Ah, yeah, of course. Oh, sorry. Wait a moment. Why is it printing it so many times? Showing. Ah, right. That's still from the. Stop it. That's still from. I forgot to remove that. That print statement. Where's the showing text here? Remove this, please. Okay. You see? Yes, here you go. Look at this. Ball 1 has speed Vy, and there's something with e minus 17. That means it's time 10 to the minus 17th. It means it's the velocity on the x is 0.0000017 times, and then there is actually 16 times, and then there is 6. Right, 6, 1, 2, 2. Same thing here, right, for the Vy. That's the problem. And that's because we are involving sines and cosines. And hey, that makes music. Makes mathematicians, numerical mathematicians, it gives them a job. And it also creates music. That's numerical errors for you. Huh? I mean, those can be very bad, right? If you're designing the computer system of some car, right? Stuff like that. Like when you brake, there's a signal, something happening, and the car needs to brake to do some emergency action, and stuff like that is involved, right? Stuff that you should be 0, but it's like 0, and like 17 zeros and then a 1. That's not good, right? In those scenarios, like in but here, it's cool. So let's try. That's cool. I am curious what happens if the square is actually aligned with the box. which is what I was actually thinking initially. I think this is, by the way, is the coolest one I've made so far. Let's briefly try with 5. I think I tried already, right? 5. Let's make it a bit faster because ain't no other time for that. Ah, yeah, right. I remember this melody. This is getting cool. Let's try 3. I almost touched it. This is quite cool, I'll admit. Very humble. Sorry, what was I? Yeah. Let's try. Let's put this to false so I don't go damn crazy. Let's try to rotate the square properly, right? So it goes well, not just the square, right, but all the polygons, like see, even this, the triangle doesn't really start like you expect a triangle to start, right? So how do we fix that? We have to add. Why is that happening? You have to understand. So we are dividing, like in this case, right? We're dividing 2 pi times 3. We have a center here, and we do the first theta. The first angle is 0. You compute this point. The second angle is 60. Is it? No, it's 120. 120, 240, 360. Yeah, it's 120, right? We add it. But what I actually want to do is to, I guess, split the first. Oh, I think I have to add some constant offset. So, well, I have to start instead of so I can do it in a few ways. First of all, let's try this. To do the same thing, but just with a different algorithm, which will then be better for later. So we always add one increment, right? Which is, what is it? 2. It's this stuff here divided by n. This should be the same as before. Yes, exactly. But now, and by the way, sorry, let's make it modulo. Let's make this modulo to pi, just so that if I go over for whatever reason, like I shouldn't right now for how this 4 is written, but I will in a moment. I might in a moment. Modulo, can I make modulo a non-integer? I guess I can. Now if I start, now the cool thing about writing it like this is that I can start right from I don't know, math.pi, and this exactly, this will rotate. Okay, so how do I, what thing do I add it to have it horizontal? I have a hunch, at least for the triangle, it should be 1 increment divided by 2. Okay, so math, math.pi divided by n. Let's see if that's true. No, not true. If I divide it by 2, so now n is 3, right? It's upside down. If I divide it by 1, it's like that. If I multiply, no, this won't change anything. This will be like the beginning, yeah. I have to, so this, I have to think of this as staying on a circumference, right? And I want to rotate it ahead, how much? If I went, sorry, it's divided by 6. Yes, and you know how I got it because it's the increment that is this divided by n and then divided by 2, which in the case of n for here it gives you 6, right? Yes. Let's see if this works for other n's. No. So that was my intuition, but yeah, it works only. Okay, kind of works, I guess. That's a special case, I guess. For what happens with 2? Well, yeah, there will be like that. Huh. I guess it's not. Is there even a general formula for what I want? Because it's. I mean, I want it to look like this is not a square, right? This is not how. Well, this is not how we draw a square. But how do you define this? How we draw a square? It always should have the base, the bottom base horizontal. That's the definition, and that's yeah, I'm sure I can obtain that easily. But hey, let's try this. Why not? We are in it for the music, right? So. Yeah. Okay. Now this is also cool. Huh? So now we have another initial parameter that changes everything. By the way, another type of sound that would work well is something like a xylophone, like some percussion, some pitched percussion, or how do they call that? The African. I love that sound. I always forget the name. Balafon. Digital balafon. Let's see how this sounds. Why so low? Maybe it is. Well, I'm not sure I like this. Yeah, it's taking a while to load the synth. Sometimes between, or it's just not working for whatever reason. Let's keep here balafon, right? This is cool. I think I like this. This without actually, it's refreshing to have something without delay. But yeah, this is another. We could do something. Okay, so all these parameters, if you think about it. Except this little balls. This actually I could move. I don't need it here. Let's have it here. Or am I using it? I'm using it also in draw. Okay, then no. Let's have it here. But basically, I'm now. Okay, this is also. There, but all these parameters here, right, affect. This is like the initial conditions for the sound. Like they, in theory, this is how we compose now. By changing this stuff, this is a sequencer. What I just programmed is a sequencer that's controlled by these parameters plus this one here, right? I can call this. Let's call it. Let starting theta equals this, and now, yeah, right. Because I can change this, I can play around with it, and for each value, we will have different things, right? It can be 0. In this case, it will be the same, right? But let's say that we go up to 12. another of the things. So I'm always thinking, right? Why does it sound? So it sounds much better, I think, than it ever did. And by the way, of course, yeah, it also depends exactly on, right? Not all of these choices are gonna sound cool, right? I can't expect that, but still, I think maybe just thinking here, maybe another thing I could add is to have some balls not participate in the collision against each other and only on the walls. Like have some balls that go like super slow, like huge balls that are slow and they move around, and when they touch the borders, then they make a like a loud noise, like a drone. But otherwise, they don't interact. They're like maybe you can even draw them right, like more foggy. Uh, they don't bounce. And then on top of that, some balls like this that move faster and interact more and have a different sound, more rhythmic. Yeah. Well, this is good and interesting. Let's make a few more experiments. So I think we can maybe I should maybe write down right the things that were cool. But no, I have the video. I can always check back at the video. But the thing, just to recreate it one last time with the square, with this was cool, right? Yeah, this, but also the one with 0, like both were. So if we re-enable the sounds. In this we could have a slightly bigger balls, I think, for this. Which would just change the speed, right, at this point. Oh, kind of. Might change actually even the rhythm. Or I could have sometimes I could have balls being generated and disappear, right? Like a life death cycle kind of. Like sometimes you see this trail, sometimes that a ball could detach out of the trail. And maybe a ball after a certain number of collisions could disappear. It's like, it breaks. Okay, well, this is one. This I think was the other that was interesting, yeah, because this is actually best. And it starts really slowly to open up because the rhythms shift. To be honest, this is quite cool. I could make a video out of this. So because then my objective, right, would be to, once I have something like this that just goes on, it looks and sounds cool. Still, there's some more work to do, but I think this is not bad at all. Once I have something like this, make a 1-hour video out of it. Just let it run overnight, for example. Record it in full screen, and and then post that as a video. That was my initial motivation, right, to start this series of live streams. I think I might have something already. I mean, like, the graphics are nothing to write home about. I think the sound is actually fine. Like, yeah, the sound, it's not annoying now, right, for now. It doesn't have that reverb. Because with all these notes so crowded, they should be short. Each note, they shouldn't be annoying. Another thing I could do actually. Huh. Now it's cool because I get to define my own rules, right, in this thing. So now when there is a collision, right, between two balls, only one note is being played, and that's kind of random in the sense that it depends on how they're initialized. Whatever, I won't get into it now, but it depends on the, well, there's this this loop, right, where I check, like, for each ball it's a double 4. For each ball I check all the other balls, and the index you see of the balls in the array counts, right? Because if I check if the ball I and J are colliding, and I is smaller than J, what was that? I is smaller than J, then and I is smaller than J, then it will check this thing only for one ordering of the pair, and it will move, right, when it detects a collision. Not only it sends, well, actually that the MIDI note will be sent here, but it will do the movement when they collide. It moves them so they don't collide anymore. So then when it checks the other pair, actually it doesn't even check the other pair, because each time I'm starting from I+1, so I check each pair only once in a specific order. But sorry, I'm getting sidetracked. No, my idea was, so one emits a note, but it could bump the note of the other, like the other ball. It could be like, instead of having just one note assigned to each ball, you could have an array of notes assigned to each ball, and every time it gets pushed by another, it moves the index, so that at the next collision it will play another note. That's interesting, potentially. But until I stay on the pentatonic, in the end doesn't even make that much of a difference, to be honest. Like, there's so much that will, again, just kind of add more variation, but now the problem is not so much with variation, it's more with structure, actually. This has been going on for minutes, and yeah, I think, let's see, okay, if I wanted to record this, like, how would I do it? So maybe I might do it later today off stream, but at least I want to figure out how to do it. So what happens if I just press full screen here? I get this. Okay, well, that's it. Then I just create a bigger canvas, right? I just create a bigger canvas. But it has to be the size. And then I have to scale everything, right? For it, like, if I just make a bigger canvas here, say, the rhythm will change, right? Plus, it's not square. Wait, but did it start in the center? Oh, why is that not in the center? It didn't start in the center. Aha, okay. Very bad. That canvas width, okay. That canvas height. And then we use them here. And here. Okay. Format. But it's off screen now, huh? Yeah. Let's see if there's a P5JS record sketch full screen, something like that. Maybe there's a that was full screen mode or turns. Let's try this. Press shift space. If the mouse is inside the sketch, we split the state of the full screen here, but this is not what I want. Record the sketch. By the way, yeah, I have to of course record the video and the audio coming out of BitTwig, but okay, it does have some facility. There's a media recorder class. It sounds relevant. Query selector canvas. So this picks the canvas element in the HTML, and then capture stream. Is this a what? Where does this come from? Export video. This is probably from P5.js on the stream. Record on data available. This gets, I guess it's a callback function. There's a chunk of data and it gets pushed to an array. Yes. And then export video. I guess this kind of saves. It creates a URL to download the file, which is created like this, right? A blob, because then it creates the blob out of the chunks, and then it creates an URL object. It creates a link, which gets clicked, so you download the video. But how do these things get called? You create a canvas. Okay. And you call record. Ah, by the way, you can set the frame rate. Yeah, which I guess is important to record. Yeah, you pass it here, right? So it calls this function record straight away. Well, let's try defining frame rate. Frame rate equals 30, and then set up those sketch frame rate. Does this change anything? Yep. The frame rate is not a function. Frame rate is not a function. Was this higher before? Looks smoother. Oh, okay. What's the default? P5.js default frame rate. So the frame rate, yeah, it's 60. Okay. Okay, the frame rate dictates, of course, the whole speed of the simulation. And then let's try it, huh? Well, let's try it first here in this sketch of theirs. So I have to click something. It's writing. Yeah, it's writing something here. And yeah, I guess okay. I'll check this some other time. Okay, well, but in any case, yeah, made a lot of progress, and yeah, we have something cool. I'll figure out how to record this, and maybe soon make a video out of it, and yeah, and then go on from here. Next steps. So, what are future directions here? I mentioned, right, possibly having balls that don't collide. Well, having other set, actually before that, right? So now I did this polygon thing, right, where they all start on the polygon and they go inside. That's one idea. I could have another idea where they just go, they just start in a row and they go vertically. or literally manually defining, right? Have one ball here that starts with the speed in this direction and another here and that, and just like figure it out. Maybe defining a grid and choosing some points on this grid as starting points for the ball. Yeah, I guess yeah, just basically playing around with the configuration, and then the visuals. Okay, now they are cool, but I'm getting already bored of them. I think they should be more flashy. It should be more entertaining to watch. So I want more flash, more like some glitter or something. I don't know. The background should be like galaxy or something, and yeah, whatever. Should be more entertaining to watch. But yeah, with that being said, thanks so much for watching, and I'll see you soon. Bye bye.